this is what we did Wednesday. Okay. Oh, by the way, my bad. These are supposed to go to the library, so this is for today and for Wednesday. So if you were there, sorry about that. They're going in the library. Remember, if you miss a lecture or something, you can go to the library, and these are the complete slides. And printed out homework that's also available under doc sharing from the eCompanion site, which I'm kind of behind. Let me know if you ever go there and it's not there, okay?
Was it up there this week?
It may not have been updated,
Okay.
so I'll do that before I go home. So yeah, sometimes I kind of get behind. So we're going to do a stoichiometric calculation, and all a stoichiometry problem is you have the amount of something and you want to get the amount of something else. So in this case, we had the amount of magnesium, and we were trying to get the amount of oxygen. We had the amount of magnesium, and we were trying to get to the amount of magnesium oxide, okay? Notice these amounts happen to be in moles, right? The problem is, and this is what we need to do today, usually it's not given in moles. Usually it's given in grams. And usually you don't want to stop at moles. Usually you want to go to grams. Okay, I'll show you what I mean. But it's a stoichiometric calculation. It's very similar. This is what I call, this part is what I call the heart of the stoichiometric calculation. It usually goes from grams to grams. You basically go through moles, which is what we did the other day. Are there any questions about this? Remember what we did yesterday, or Wednesday, was we used the coefficients associated with the balanced equation, okay? This 2 came from the 2 in front of the magnesium oxide, and that 2 came from the 2 in front of the magnesium, okay? There's a 1 in front of the O2 implied, and that's why there's a 1 there. Again, the 2 came from the magnesium. Okay, so that's kind of our ticket to relating moles to moles of something to something else. That's just kind of a reminder. All right. So, get your pencils ready. Now, I want to know what you want to say. So we're going to do the same reaction. Okay, so we have the balanced equation here. But instead of moles to moles, we're going to go from mass to mass. So, and a lot of times when I'm faced with this, I will write underneath the species what I know about it or what I'm trying to get. 6 species. So like for this one, it says what mass of oxygen, so question mark grams under the O2, okay, is needed to react with 0.30 grams of magnesium. 0.30 grams. Okay? So it's just a way of kind of lifting out from the words what we're trying to accomplish. All right. So this is more of a typical stoichiometry problem. Right? So we know how we can get from moles of magnesium to moles of oxygen, just like we did on Wednesday, using a ratio, right? From the balanced chemical equation, since we want moles of magnesium to cancel, we would put those units down here, moles of oxygen up there, and what the coefficient in front of the O2 is 1, and the coefficient in front of the Mg is 2. Okay, but you cannot go directly from that 0.30 grams. You can't go directly from that 0.30 grams of magnesium to grams of O2. You can't go directly, but you can go through moles. Okay, so you can't go directly from grams to grams using that 1 to 2 relationship, because that 1 to 2 relationship is with regard to counted particles or moles. So, just kind of streamlining how we do this. This has kind of got almost a rhythm to it. We can go from grams of magnesium, we know, to moles of magnesium. How? Molar mass, exactly. And then the heart of the heart of that sort of problem, I can't say today, okay, is a ratio, stoichiometric ratio, which in this case we're pretty sure we're going to have to go, the 1 mole O2 over 2 moles of Mg. That's what's going to go right there. And then you got to finish off going from moles of O2 to grams of O2 using It's molar mass, exactly. That's it. Okay, so I kind of tease, but this is like the heart of the calculation, okay? And basically we tack on grams to mole and a moles to gram on either end. So, doesn't it look like the heart? Okay, so this is where, I'm going to pass it around. So let me go ahead and get you started. We're going to knock out for everything. You don't always have to do this, but for the species magnesium, oh, I guess, okay, I got the builds here. So if you would, and some of these are easier than others, I'm going to pass this around, and you need to write next to that what its molar mass is. And if you have to put anything in your calculator, or if you have to multiply something by 2, write it out. Okay? And then don't forget your units. There it is. Perfect. So we know we're going to use the first 2 molar masses. The third molar mass we're going to use here in a minute. So. Oh, but how did you get it? Oh, Mrs. Snipes, you're so anal. I'll take email. There you go, sir. Thank you.
Why would you say that?
What?
You're making my confidence go down.
It's going to get harder as it goes on that side of the room, so be prepared.
Thanks.
Thank you. Okay. So my turn. Let's see. I can't remember what the next thing is. Very good, guys. Okay. So I'm going to kind of talk you through this, and we are going to go ahead and start with you, Jason. I'm going to diagram up. I'm going to diagram up how we're going to do it. Did it go backwards on me? Okay. So the solution, I want you to just to do part at a time. So no, it's not going to get harder. And I'll show you what I mean. We were given the mass of magnesium. And Jason, I just want you to do this first part. So I want you to start out with 0.30 grams mg over 1. And I want you to go to the side. Just that side. And then the next part is I want you to go from moles of magnesium to moles of O2. Okay, and then Tyree, moles of O2 to grams of O2.
Glad you're walking us through this.
Oh, good.
You wouldn't know where to break it. You just do it all.
So, oh, it's not writing. Sorry. If I hand it to you, it's not writing. You just need to tap that pencil up there. And you know it's able to write where you want to write. So you guys will be experts with those here. Yeah, heck yeah.
Oh, then I'm sorry. Oh.
I guess then if you don't mind tapping it out. Because usually I have the last term.
I'm gonna attempt to.
Okay, actually, all you need is this one right there. That one,
Oh, just.
two.
Oh, okay.
So hit that eraser. Cool. And then hit the pencil back. That's a marker.
Ready to pass on? Okay. What is it you want me to put in here?
And then, so you, go ahead and cross out, would you, Tyree, what units cancel so far?
Okay.
So, and then go ahead and use the molar mass of the previous slide of oxygen to get to grams of oxygen.
So 32. That's grams, right?
Yeah, and go ahead and say grams O2, because you got two things in there, very good.
And then on the bottom it should be 202? Or one.
One mole of O2.
Okay.
It's pretty rough, but Kelsey crunched it in a calculator. So remember, but remember that what she's doing is, and there's a number of different ways to do this, but you kind of think of all the numbers in the top, like the number-wise, because the only units that you got left is grams of O2. So you have a 30, skip the ones, you have a 32.00.
Is that right?
You have that 24.3. And also in the bottom, you have a 2. Okay, so that's your numbers, what you have going on.
Is that right?
Heck yeah.
Okay.
And she gave 2 sig figs, does that make sense?
So we're 2.
Perfect. Thanks.
You'll be able to do these in your sleep. So it's a mass to mass problem through moles. Let's do another one. And we're over here with you, Andrew. Okay, so, oops. Okay. What? I think I must have skipped a... I'm going backwards. What magnesium? That's... Okay, so this is another problem. Okay, I was like, what? So what's different about this problem? What are we after with this problem? Right. So we still have 0.30 grams of magnesium. Okay, and notice where it said sufficient, I'll put that under the O2. And then actually in Monday's lecture, we're going to say that sufficient actually means probably excess. probably, i.e. excess. And so what we're trying to get at are these grams. So just to kind of, and I've almost got the question posed. Okay, so it looks like, I better hit the button thing. Okay, it's not green yet.
So look how similar it is. Actually, the first two terms are identical. And they're the same equation like deja vu. So we still have the same mass of magnesium. We're going to go to moles of magnesium. But this time, instead of moles of oxygen, we're going to go to moles of MgO, magnesium oxide. And then we're going to back out to grams of magnesium oxide. So if you would, Andrew, do that first step. Perfect.
Easy one. Oh, great.
And then I like how you did the moles of magnesium. I'd probably put 24.3 grams of magnesium. So then grams of yours. So now he's going to go from moles to moles. He's going to go from moles of magnesium to moles of magnesium oxide. Moles of magnesium oxide. And he's going to pick off the relative, he's going to pick off the stoichiometric coefficients with relative moles.
So,
He's not going to reduce it.
It's gonna be mole of MgO, moles of magnesium oxide.
So, 1 to 2?
Yeah, 2. Or is it 2? It's 2 on top.
Magnesium oxide and 2 moles of magnesium.
Does that make sense? But it's going to be, these are going to be, want to insert the term moles, 2 moles magnesium, 2 moles. Sorry, 2 moles magnesium oxide, 2 moles magnesium.
Okay, how did you know it was 2?
Because,
Oh, there's 2 up there. Okay.
yeah,
That makes sense.
for every 2 moles of magnesium and 1 mole of oxygen makes 2 moles of magnesium oxide.
So those coefficients are
Darn
talking about moles.
chemistry.
That's okay, I did. Sometimes I'm at home by myself, I'm like, somebody's cursing me.
sorry.
Okay, so then this is gonna be the
So the last step that Chelsea's gonna do is go
43
from moles of
1
magnesium to grams of magnesium, sorry, moles of magnesium oxide
side.
to grams of magnesium oxide.
So then this would be 1.
She's gonna use Matthew's term.
It's supposed to be MgO. I can't fit it up there.
MgO.
Is it gonna be 1 mole? Yeah.
That's MgO.
Okay.
Very good. Cool, cool. And then on my way over here, I just want to emphasize that you can make sure, do you see where unit-wise, the grams of, better color. So kind of going across, the grams of magnesium have canceled. The moles of magnesium have also canceled. The moles of magnesium oxide, the units, have canceled. And we have units of grams of magnesium oxide, which is what we wanted. Without further ado, ding, ding, ding. Perfect. Very good. It's just a rhythm sort of thing. I mean, it's very, very standard. Go grams of something to grams of something else. Okay? Okay, so, thank you. Oh. Builds, 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 builds. Did you get -0.30? So what we did actually, I don't know how to say this. If we write, I'll go ahead and write the unbalanced equation. And we have kind of come full circle. And sometimes students will say, well, could I just have, for that last stoichiometric calculation, could I just use mass balance? And yeah. Remember, we said unbalanced equations, although they may hurt our eyes, they tell us qualitative information. So we started with 0.30 grams of this, and we said we would have to consume 0.20 grams of this. This is like our recipe, okay? And what it would make is 0.50 grams of magnesium oxide. We did these as two separate calculations, okay? But like the slide says, it kind of makes, not kind of, it does make sense. We should have the same mass, bless you, on the product side as we had on the reactant side. Does that make sense? So, bless you. So you could have gotten to the mass of the product by adding those two masses. Okay, you ready to do it again? Yay! Okay, so we're going to pass it around. It's kind of fun because we're staggered because we started over here and now we're going to start right here. Okay, so what I want to do is to knock out all 3 molar masses. We're going to work 2 problems, just kind of like we worked 2 problems before. The first problem is going to be this, okay? And again, you know, if you find comfort like I do in kind of writing underneath the species what you're after, what you know about it. So it says, what mass of P4, so question mark grams of P4, is needed to react with 1.25 grams of Cl2. 1.25 grams of Cl2. Okay. So we're going to work a second problem in which we're going to be working with we're going to be after the product, just like we were after the magnesium oxide before. So let's knock out the molar masses of everything. Oops. Guess you can't because I did it for you.
Thanks.
I know. My bad. So if you were going to knock out the molar masses of everything, this is what it would look like. Now this is where you say, do we still get 10 points? Actually, this is an important step though, all kidding aside, because a lot of times students will want to, and I kind of understand while you're writing, I'll kind of tell you the problem I run into. Sometimes students want to put that number 6, they want to ball that in to the molar mass of Cl2. Now, 6 has nothing to do with the molar mass of Cl2. Don't fight it. I'm telling you, that's what I see. So it's very important that you see kind of in your work, before you work the problem, to go from grams to moles or moles to mass at the end of the problem, at the beginning of the problem. When you're working out the molar masses, you don't do anything with the stoichiometric coefficient. Okay, that's for the hard part. Okay? And do you have to show this to get full credit? Yeah. You know, but it can save your butt sometimes. Because, like, if your finger slips, I can be like, oh, well, they showed me, but they just used the wrong number. Or it just, the stars weren't aligned or something. Okay. So with that in mind, let's work that first problem where you have 1.25 grams of, is it P4? Cl2? Okay, 1.25 grams of Cl2. So I'm going to erase this. So if you would, Heather, do the first problem where you're going from the mass of the Cl2 to the moles of the Cl2. And then we're going to go back to Matthew, and you're going to go from moles of Cl2 to moles of P4. And you're gonna go from moles of P4 to mass of P4, and you're gonna knock it into your calculator.
It just comes up on it.
Right, use the molar mass to get moles, yeah.
You did it for us, at the end.
I did? Oh, crap. So weird. Okay. This will not be. Excuse me. Hi. Hi. Get away. Get over here too. I must have just gotten sidetracked. Oh yeah, we got that one coming up. Look at all those calculations. Yay! One more. All right, now I go back. Go back to here and delete. Oh, that is That's where you're finding the mass of the problem. And this one. More masses. Don't look. And then this one. Oh yeah, oh yeah. I'm hoping if we do enough of these, you'll be like, when you go home, you'll be like, yeah, I remember doing all that. Enough that we get. Okay. So, you're up here. I think that'll do us. All right, oh, and then take the pencil. Perfect. So, let's try this again. We're gonna go from the mass of the Cl2 to moles of Cl2. Perfect. Mass is gonna go from moles of Cl2 to moles of P4. Whoops. Set you up. I think that looks good.
A third
Gonna
of 6.
use, yeah. Perfect.
questions? That looks good. See, if you could only take a group test. Perfect. I'm liking it very much.
Okay, so moles of Cl2 canceled, we're left with moles of P4. Now we need to go from moles P4 to mass of P4.